Good morning, students. In this video, I will be solving question from NCERT of the chapter of Bohr atomic model. So, in a simple glance, if I write here Bohr theory, the postulates of Bohr theory I have given you that first of mathematically mvn square upon rn is equal to 1 upon 4 pi epsilon 0 or jd square upon rn square. First postulate. Second postulate, mvn rn. Electron can revolve in that one orbit in which its environmental is integral material of h upon 2 pi. Then electron lose energy or gain energy when goes from higher to lower path. So if electron jump from n1 to n2, energy emitted by this. Using these, I derived the radius of the orbit Rn. That was epsilon 0 n square h square upon pi z e square m. The radius of the orbit. Let me verify again. No wrong concept should be go. Yes, epsilon 0 n square h square. And from here we find that radius of the orbit proportional to n square, because epsilon 0 h pi z e 4 m e square all are constant values. Then velocity Vn. Velocity Vn was there jd square upon 2 epsilon 0 into nh. Velocity of electron orbit. Then I derived the external energy that En was minus sum of kinetic potential. We keep on doing, and finally we get energy of electron. Z square E4 m upon 8 epsilon 0 square n square h square. And using this, when we put the value, I put that energy of electron in nth orbit minus 13.6 upon z square upon n square electron volt. For hydrogen atom, Ze1, so for H atom, En equal to minus 13.6 upon n square electron volt. And something which is very important here, when we write this external total energy, it is sum of kinetic potential. And if total energy of electron is say minus E, then kinetic energy equal to plus E and potential energy minus 2E. So these are some facts And then later on we derived 1 upon lambda equal to r z square 1 upon n1 square minus 1 upon n2 square formula. R Rydberg constant and r equal to, it was there, z e4m upon 8 epsilon 0 ch cube. Rydberg constant, yes, E4m upon 8 epsilon 0 ch cube, and by putting the values, its value come actually 1.09 10 to power 7 per meter. For Lyman series n1 equal to 1 and 2 equal to 2 to 3. For Lyman series, the shortest wavelength and for shortest wavelength n2 will be infinity. Balmer n1 बराबर 2 n2 बराबर 3 4 5 6 on. For shortest wavelength Balmer series n2 infinity, like that. So these are some topics which you have keep in mind. If n equal to 1, energy minus 13.6 electron volt, and if electron is first orbit, it has lowest energy, and the electron is said to be in ground state. The first orbit of H atom is called ground state, and if electron go in from first to second orbit is called first excited state, and third orbit is called second excited state, fourth orbit third excited state. So these terms are used. So now I take here one question for you. 12.3. Yes. What is the shortest wavelength in Paschen series? For Paschen series, it is 12.3 of NCERT book. 1 upon lambda is equal to r bracket 1 upon 3 square minus 1 upon n square. इनके n2 square है वो, n2 equal to here taken 3 4 5 6 4 shortest wavelength of Paschen series. And 2 equal to infinity. So 1 upon lambda equal to r upon 9, or lambda equal to 9 upon r. And I told you that value of r is 1.09 10 to power 7. It will come out in meter. So it will be 109 or 900. 900 upon 109. And now 10 to power minus 7. You divide it, you will get the answer. This must do, and please get your answer verified from NCERT book. It is given there. Please solve it all yourself in your handwriting. The topics which you learn, you should write by your own pen in your copy and practice 2 or 3 times. Only then you can solve. It looks here very simple when we do problem, but when we solve ourselves, we find ourselves in trouble and it takes times. Now 12.4. The difference of 2.3 electron volt separate two energy level in atom. means the difference of two energy level is 2.3 electron volt. What is the frequency of radiation emitted when atom makes transition from upper state to? There are two energy levels. Their difference is gap. डेल्टा ई जो गैप है यहाँ वो 2.3 इलेक्ट्रॉन वोल्ट. तो हाउ मच? तो व्हाट विल बी द वेवलेंथ एंड फ्रीक्वेंसी? What is the frequency of radiation emitted? Only frequency you are asked. So you know H nu is equal to delta E. When we are learner, we commit so many mistakes. We put in 2.3 only. H nu. Actually, it will be in hertz when it is in joule. 1.6 10 to the power minus 19. Convert electron volt into. I think now you have got it. Your brain picked as 1 electron volt 1.6 10 to the power minus 19 joule. 1 इलेक्ट्रॉन वोल्ट, इसको याद रखें. ऐसे 1 मिलियन इलेक्ट्रॉन वोल्ट भी होते हैं 10 to the power 6 इलेक्ट्रॉन वोल्ट. That will come out 1.6 10 to the power minus 13. हमें अपनी बुद्धि को पूरा इस्तेमाल करना होगा, तभी हम कुछ कर पाएंगे. ऐसे नहीं होता भाई. तो न्यू इक्वल टू 2.3 into 1.6 into 10 to the power minus 19. सॉरी, देखो मेरे हाथ से गलत दिखेगा. अपॉन h 6.6 10 to the power minus 34. Calculate the simple. It will be in hertz or per second. 16 is 48 4. 16 is 34 4 36. Decimal after 2 upon 6.6 10 to the power, subtract it, you will get 15 plus 15 now. You divide it and get the answer verified from the book. Please, I will not solving here. You have to do it yourself. You know? Simple. Here I am going to tell you the method. You please get ready and prepare yourself. Unless you do practice, you can't learn. जब तक आप खुद हाथ से नहीं करेंगे, आपसे सवाल नहीं होगा. 12.5 is simple question here. Many times it is asked in that way. हाफ मार्क में आएगा कहीं. Ground state energy of electron is minus 13.6. I told you that E1 minus 13.6 electron volt. Total energy of electron in first orbit. First orbit of H atom is called ground state. Ground state energy level. I told you the electron when remain in any orbit, it neither loses nor gain energy. That is what is called a stationary energy state. Every orbit is called stationary energy state. So minus 13.6 is the energy of total energy of electron. So you are asked what are the kinetic energy and potential energy of electron in this state. I told you kinetic energy will be plus 13.6 and potential energy minus twice of 13.6 electron volt. 27.2 electron volt. Remember, this question actually asked other way. कई बार बड़ी once I will be telling you the question here. Later on, they mix the topics. Hydrogen energy level was related with de Broglie wave, and many learned people were sitting with me. They were all confused. So when learned people are confused. Learner तो हड़बड़ाएगा, उसको तो पता ही नहीं चलेगा ये हमने क्या करते हैं, तो इसलिए प्रैक्टिस करिए. तो दिस वाज सिंपल क्वेश्चन. नाउ 12.6, a good question and has been asked many times in board exam. These questions are from NCERT book, volume 2. NCERT से हैं ये क्वेश्चन सब, volume 2. 12.6. Question says here, a hydrogen atom initially in the ground state absorbed photon which is excited to n equal to 4 level. Determine the wavelength and frequency of photon in hydrogen atom initially ground state level. A hydrogen atom initially in ground state level absorbed photon which excited into fourth level. So what is the wavelength and frequency of photon? भाई ग्राउंड स्टेट में यहाँ इलेक्ट्रॉन था और 2, 3 और 4 में बचा दिया उसने. तो we have to calculate how much energy was of this photon first. तो we know energy En बराबर माइनस 13.6 इलेक्ट्रॉन वोल्ट अपॉन n स्क्वायर. So E1 is equal to minus 13.6 electron volt. E4 minus 13.6 upon 4 square 16. है नहीं? और D minus 0.8 16 area 128.5 electron volt. So how much energy is gained by electron equal to energy of photon. So here a photon fall on this excited to this energy level. It is 1, 2, 3, 4. So energy of photon. Energy. Energy of photon. Minus 0.85 और माइनस 13.6 यानी कि 13.6 प्लस और माइनस 0.85. Subtract this 13.6 0.85 5 and it is 15 minus 7 12.75 electron volt was the energy of this photon. You know, the photon of this energy will lie in which region of spectrum of electromagnetic wave? It will be in ultraviolet region. So you are asked frequency and wavelength. So we know delta E equal to hc upon lambda. So lambda equal to hc upon delta E. 6.6 10 to the power minus 34 C3 into 10 to the power 8 upon delta E 12.75 into 1.6 10 to the power minus 19. Here this energy has to be placed in joule. ये गलती होती है एग्जाम में. So please solve yourself. How to solve this? Very simple. 3 4 जा 25 6.6 10 to the power 19 और 27 तो माइनस 7 बचेगा अपॉन 16 5 जा 88 16 to 32 और 8 44 16 4 64 और 4 68 decimal after 3 so it is 6.6 upon 6.8 into 10 to the power minus 7 meter. You can divide it 0.9 कुछ आएगा 0.825 होगा 66 divided by 68.0 है भाई 9 जा 9 8 जा 72 9 6 जा 9 9 7 9 8 7 7 और 9 6 जा 54 और चलेगा 9 9 8 जा 72 carry 7 9 is 54 61 yes so it is here 8 or then 4 0 sorry 0 here 6 7 ja 7 8 ja 56 5 7 42 5 47 yes it is 0.97 10 to the power minus 7 or you can write it as 9.7 10 to the power minus 8 meter यानी कि it is 970 nanometer so it lies in ultraviolet region now frequency nu is equal to c upon lambda c3 into 10 to the power 8 nu is equal to c upon lambda 3 into 10 to the power 8 upon lambda 9.7 10 to the power itne hertz you can solve it and get the question verified answer so these are some questions here I will be telling more questions in next video the time here in this video 22 minutes बच्चे हो जाएंगे बोर अगर ये और लंबा हो गया प्लीज़ लाइक द वीडियो शेयर एंड प्लीज़ स्टार्ट स्टडिंग केयरफुली नाउ very less time is left with you